Today we're going to talk about different ways of estimating with decimals. So remember, an estimate is a rough guess. So if you're adding or subtracting with decimals and you don't want to mess with going through the steps of the actual addition or subtraction, you can use estimation to figure out about what the answer would be if you're finding a sum, which is adding, or a difference, which is subtracting. There are 3 different strategies that you can use to estimate decimals. We are going to look at each of those 3 strategies so that you know what they are and you have them available to you when you would like to use them. The first strategy is the rounding strategy. We're going to look at an example problem, and we're actually going to use the same example problem 2 different ways so you can see the difference between 2 of the different rounding strategies. So this is a decimal problem where we are adding decimals, but we're not going to actually add the decimals. We're just going to estimate the answer. So when you're using the rounding strategy, the reason why it's called the rounding strategy is because we're going to round the decimals off. And specifically, we are going to round to the nearest whole number. When you're asked to round to the nearest whole number, basically what's happening, rounding to the nearest whole number is the same as rounding to the ones place. So that means that we want to round these decimals off using this number. So thinking about what we reviewed with rounding, we would look at the number after that to decide what to do. So 6.75, 7 is greater than 5, so we would round up. So that would turn into 7. 4.37, the number after it, is less than 5, so that means we would round down and leave the 4 alone. So if we're estimating by rounding, this turns into 7 plus 4, which just made this a very easy problem to do mentally in our head. So that means that this answer is going to be about 11. So that's how the rounding strategy works. There is a different strategy that is a little bit like this, but not exactly the same. It's called front-end estimation. Front-end estimation works a little bit like rounding, but rather than rounding the nearest whole number, we're basically just looking at the beginning of the number and ignoring everything that comes after that. So if we have our decimals again, same problem. Rather than actually rounding the number, what we're going to do is we're basically just going to look at the beginning of the number. So in this case, we would look at the first digit, which is the ones digit. So that's the leading digit or the first digit in the number. And we would just add or subtract the leading digits. So in this case, I would just look at the 6 and the 4. 6 plus 4 gives me about 10. So that's a little bit different than what we got with the rounding strategy, which was giving us an answer of about 11. 10 and 11 are only 1 digit apart. They're in the same neighborhood. Remember, we're estimating. Estimates aren't exact. So both of those are reasonably close to the actual answer. One thing to be aware of with front-end estimation is that if you need to, you might have to add some zeros into the problem. So for instance, we're going to do one other front-end estimation problem here. So this is another problem. If you're going to use front-end estimation, then we would look at just this first digit. So in that case, with both of these, that's the tens digit that we're adding. So we have to remember that that's the tens digit. When we're writing the number back out, we might need to add some zeros between that number and where the decimal point belongs. So since this is the tens digit, there's a ones digit in there. So the decimal point always goes after the ones digit. So in this case, we would have to add a 0 in. So 53.27 plus 31.87 is about 80. So when you're working with front-end estimation, sometimes you have to add zeros between the number and the decimal point if you're working with numbers that are not the ones in the ones digit, in the ones place. One thing with front-end estimation to be aware of, if you compare your front-end estimation answer, the 10, to the rounding answer, the 11, you'll notice that that's lower. So front-end estimation will almost always give a sum when you're adding that is lower than the actual answer, which makes sense if you think about it because you have these extra pieces on here and you're basically chopping those off. So when you chop those off, it has the same effect as rounding down. So when you round down, that's going to make your answer appear smaller. So front-end estimation is nice because it's fast, but the downside is that a lot of times it'll give you an answer that's a little bit lower than the actual answer. But if you just need a rough estimate and you don't care about being exact, it's a nice fast way of getting the answer. Now, there is one other estimating strategy, and this strategy you would use when you're working with estimating groups of numbers, and this strategy is called the clustering strategy. So clustering you would use if you are trying to add or subtract a large amount of numbers that are all close to the same or all about the same. So in order to use the clustering strategy, you have to check to see if the numbers are all close to the same number. So they have to be around the same number in order for clustering to work. So if you have numbers that are very, very different from each other and they're not anywhere near the same number, then you would not want to use clustering. So this is an example of a problem that you could use clustering with. Let's say we have a problem like this. This would be a good clustering problem because if we check to see if the numbers are all close to the same number, they are. They're all very close to 5. One of them is 5 exactly. This one is just a little higher, or a little lower, but they're all kind of right around 5, give or take. Without being horribly far away. They're all pretty close to 5. So that makes clustering a good strategy. So to use the clustering strategy, once we decide, yes, all of the numbers are pretty close together, they're all close to the same thing, what we're going to do is we're going to round everything to the same number. So since these are all close to 5, we're going to round them all to 5. So that's 5, and that's 5, and the other one already was 5 to begin with. That just made a really easy problem. 5 plus 5 plus 5 plus 5 is 20. So an estimate of the answer would be about 20. So check to see if the numbers are all close to the same number. If they are, round everything to that number. So everything's going to get rounded to the same number and then just add, which makes it an easy problem because it's pretty easy when you're just adding the same number over and over and over again.